Hello, I'm Peter Vidjord. I'm a product director here at Ortofon. We are at our premises in the southern part of Denmark, and we are, among other things, we are a cartridge manufacturer. I look forward to show you around our factory, a bit about our production of cartridges and what are actually inside the cartridges. Ortofon was founded more than 100 years ago, and we have been producing cartridges for many years, and now we are expanding our production in both cartridge production and also parts for medical companies. Right now we are in the MC production. We have over here assembly and coil winding of the parts for the MC X series, for instance. These are MC X10. This new MC X series, it's a moving coil cartridge, so if we get really close, we might be able to see the small armature, the small cross with the 4 coils here. The 4 coils are hand wound with the help of an armature, and they are made of pure silver, this is a high purity silver. We have actually the coil wires sticking out here. These are not terminated, so they are not connected to the connecting pins yet. During playback, we have the diamond down here. We have the cantilever. For this cartridge, it's an aluminum tube. Diamond here, aluminum tube, the small armature with the 4 coils. The black part just behind it is the rubber damper, which is both the compound is made in-house, but also molding of this rubber damper in-house. This is the moving system and generating system. We have the magnet here with the front pole piece, the rear pole piece, and the pole cylinder. The function of the front and rear pole piece together with the magnet and the pole cylinder is to have all the magnetic flux lines straight here, so we are having them controlled where we have the armature. So we want it as precise as possible. Therefore, we have a construction where the tolerances are like ultra low. But again, it's small parts, so yeah, small tolerances are of course needed. It's a 99.99% pure silver. The coil wire is 0.03 millimeters in diameter, so we are in an area of very thin hair. And also the construction with this honeycomb that is made of stainless steel. It's MIM molded, so construction where you use the production way called the metal injection molding. The black surface is a PVD treatment, which both protects and also gives this visual identity. This new construction has both a very high precision for a channel balance, and also the channel separation is enormous. This is actually one of the armatures with the coils for the MC X series. Here you see the silver coil, or silver coil wire. The armature is used to keep, this fixture is used to keep the armature in place, while the operator is using fingertips to control the placement of the coil wire. It's a very delicate process because the layers needs to be completely aligned. We have a lot of machines that are doing each their own part of the production of the styli for the cartridges. This machine here does both the mounting of the diamond, does the assembly of the diamond and cantilever, places the magnet in its correct position, magnetizes it, and even place the rubber damper and the total stylus plus rubber damper in the plastic stylus part. So the first cell we have here, you can see illuminated underneath. There we have the small diamonds. In the aluminum tray, they are being placed and then later fed to the small square, and the picker will choose a diamond in place, position it in a gripper, and then together with a cantilever tube, which is in the next part of the machine over here, the small tubes that are completely straight with no machining yet, they're also being picked. The cantilever is then formed, and a hole is being punched to position the diamond. Later, you'll see that the diamond position is being controlled with the vision system. There's a ring light behind the computer monitor. The process here is the insertion of the diamond in the cantilever. The diamond is positioned and aligned before inserting in the diamond in the cantilever. And also now we see the placement of the magnet. The magnet is being placed inside the small trumpet, so the rear end of the cantilever, and later it will have a small rubber damper placed exactly surrounding the small trumpet. Now it's the rubber damper that is being placed on the cantilever, and inside the rubber damper there's a hole, and inside that hole there's a small groove that fits perfectly surrounding this small trumpet end of the cantilever. We are having inspection here for the diamond feeder. So these are the small diamonds, a quarter of a millimeter, and there you can see which direction they have. But when they are being mounted, then you'll see that for the mounting, we need to make sure that the alignment is in place, and depending if it's spherical or if it's an elliptical diamond, we'll also need the direction of the diamond, so shapes on the diamond, so the small facets. So after picking the diamond, picking the cantilever, forming it, inserting the diamond, gluing it after the insertion, forming the trumpet, positioning of the magnet, magnetizing the magnet, placing the rubber damper. This whole stylus part, all the moving parts are being placed in the plastic part of the stylus. So this is actually the final product. This stylus is a stylus Concord mix, a DJ stylus. Therefore, you will also see that it's a quite rigid aluminum cantilever. So this is sturdy enough to withstand heavy scratching and backduring. The MM cartridges, they have 4 coils. Each of the coils are mounted on one of the pole pins here, so surrounding each pole pin. The 4 pole pins are connected with a small connector down here, and the coil wires are fed through the miniature holes here and to the connector pins here. So this is what you'll see outside, for instance, a 2M red or 2M blue cartridge. So this is the connector pins sticking out, and in a moment we'll see the coils that will be mounted on the pole pins, how they are wound. The machine behind me is one of our coil winding machines. The coils wound here are for the MM cartridges. This is a pair of coils, and this is a 26 micron coil wire, and this is one of the terminals. So I accidentally bent one of the pole pins, but the intention is that they are mounted gently on these 4 pins diagonally for each channel, and then the delicate coil wire is fed through the holes and through the terminal pins. So, but let's take a look at how they are wound. Back here we have 6 coils, and right now it's an oxygen-free copper wire. It's actually a 23 micron for these coils, and they are wound as pairs. So we are doing 6 pairs at a time. As you see here, the coil wires are being gently fed through the small holes of the plastic part of this coil unit, and then after mounting of the two coil units for left and right channel, they will be glued to make sure that they are locked in place and to reduce possible buildup of vibrations or resonance. Each channel will have a set containing those two coils, and after the mounting of a small pole pin support on top of them, a metal cover will be placed, shield the coil system. Depending on the setup of the configuration of the cartridge that is being used, the coils will have 3,000, could be up to 4,500 windings per coil. A lot of people have been asking how do you in fact have one groove, but you take out a stereo signal. But the groove is aligned where you have the two different walls for left and right channel. So one punching in one direction and one in the other direction. When we then place the diamond in the groove, the diamond will pick up these modulations, and the cantilever, aluminum tube typically, will of course direct these movements to the magnet in the rear end. Then, just like we see here with the four coils, there are the pole pins, the core of the coils, they are sticking out, and the magnet will be placed in the center, exact center of those four pole pins. So you can imagine that when the magnet moves this direction, it is in average still in the middle of these two pole pins, so there'll be no signal here. There's no movement or anything collected by this channel. But the opposite channel, there we are moving the magnet in and out. So if I do like this instead, you can imagine if I have a magnet here, removing it, placing it inside, then we'll have a signal here. So that's why they are angled 90 degrees to each other, just like the groove in the vinyl. Quality control is a very important part of the production. Therefore, we have a lot of different assemblies, different processes in-house. One of the processes is actually that logos that we are having pad printed on the parts is being done in-house. For the MC X series, we chose a silver lacquer for the logos, and as you see here, it both has the diamond, the Ortofon logo, and for this one, the X10 logo. We have the pad printing process in-house for nearly all of our products. Behind me, we have the end test of the cartridges. We have a very strict quality control. You'll see that our cartridges are not only tested during production, but we also test the final product on a turntable with our own test records. This is to make sure that all quality criteria are within our tolerances, so that being both channel separation, channel balance, output, tracking capability. There are a lot of things that we are testing here on the cartridges, and this is both cartridges, Hi-Fi, DJ, and of course our most precious MC cartridges, the Exclusive series. After final testing and inspection, the cartridges are being packed and getting ready for shipment. These are some of the pre-mounted cartridges, and here they are being placed in a fixture to make sure that the alignment is precise and correct. Since the rubber dampers are crucial for the quality of the sound of the cartridges, we produce both the compound in-house, but also we mold the rubber dampers. These are some of the parts for one of the compounds that we are using. There are different parts, both some rubber compound parts where we are using raw rubber. Some are mixed with some carbon materials or particles, but also some accelerators for the vulcanizing of the rubber damper when we mold it. But we do this in-house because we want to adjust the sound of the cartridge and also the behavior of the stylus movement. So we can precisely define how will this react, how will it fit our constructions. After the mixing of the compounds, we end up with some flat layers of rubber. These are directly taken out of the fridge where they are in a controlled environment because we need a specific humidity and temperature. We are testing each batch to make sure that they have the correct Shaw value, but also the plasticity that will affect the quality of sound. Despite all things you can measure, we still need to make sure when we develop a new rubber compound how it listens, how it sounds. So some days I, together with the engineers, are listening to different rubber compounds with the exact same configuration of the magnet system, diamond and cantilever, simply to check where are we when we develop new cartridges. But let's see how these shields, these sheets get into the cartridges and how they are molded into the small rubber dampers. The rubber dampers being molded here are gently taken out of this molding tool. It's done with precaution because it's very hot right now. Inside each cavity of this part of the molding tool, you'll find one of those very miniature rubber dampers. After they are being taken out of this part of the molding tool, they will be inspected to make sure that everything is molded correctly. And this is talcum used to make it less sticky. To get an idea of the size of the rubber dampers, this is actually one of the larger rubber dampers for a Concord DJ cartridge, which are slightly larger than the hi-fi units. Just to give an idea of how the rubber dampers look inside, imagine we have the rubber damper here. This is the outside. And we see this small hole. But if we cut through the rubber damper, we have the outside here, and then we have the small hole. So we are looking in this direction and then this direction. Inside the hole we have a small cavity. So in this cavity, or this small groove, the trumpet of the cantilever will be placed, and then the magnet will be inside here. So these 2 points must interact exactly, and then at the very end we'll have the diamond sticking out.
And then the 4 poles.
Yeah. So if we cancel this and say this is the magnet, this is interacting with the pole pins and the coils here. I'm just drawing it like this. There will be, of course, the 4 coils and 1 outside here. But this small rubber damper has this small groove inside this hole, which is almost unbelievable. We have some of our products here, some historical products. As you can see, not just the most newest and fancy, but some historical cartridges. Yeah, this is the 2M series. It's one of our core products, and these are to be found on several turntables of different vendors. It's a series of cartridges starting from the tone red, going through the series to blue, which is better, bronze even better, and black. There are 2 mono cartridges. Even above the black, we have a model called Turn Black LVB 250. They're used on several turntables. Also, they are compatible with a wide range of turntables. Cartridges we see here, this is our DJ cartridges. We have a wide range. These are the Concord cartridges. The Concord Mix is one of the 3 go-to products. While the 2M series is for listening and ordinary use at home, the DJ cartridges can withstand a more heavy use, could even say abuse, because scratching and back curing is quite tough for the cantilevers. Therefore, they are built more rigid. You'll see that the stylus itself, the small tube, is more rigid and more sturdy type. Depending on the use, we have the starting point of the DJ series here, the Concord Mark II Mix, but we also have the DJ, digital and scratch, and even the club where we have a elliptical stylus. So better cartridges through the series, but also a version where you'll have even better sound quality due to an improved stylus. We also have MC cartridges, like the new introduction of the MC X series. But the MC series, they have hand-wound coils, different configuration and different build than the MM cartridges. Typically will be a more high-end cartridge. Today launched a new cartridge series, a new series of MC cartridges. This is the successor of our Quintet series, the new MC X series. We decided to develop a completely new series of cartridges. We didn't just make a facelift or decided to do a small iteration, but decided to actually do a completely new cartridge build. The series ranges from the MC X10. It features an elliptical stylus or elliptical diamond on an aluminum cantilever. We have a small armature with a high purity silver coil wire, which we are using throughout the series. Instead of having an entry-level setup using, for example, an oxygen-free copper, go directly into a high purity silver. The MC X10 is a step up from our previous entry-level MC cartridges, so this is like a very, very new, definitely a higher quality and also a higher step into the MC cartridges. We are then also happy to announce that it's only retailing at euros 299. It's a premium cartridge, completely new magnetic system. We have not just done iteration or modified an existing setup, but we actually made a new structure. So this is the core structure where the connecting terminal and the terminal pins are here. In fact, you can see it like this. The internal structure of these honeycomb is made of stainless steel. It's molded with the process called MIM or metal injection molding. The stainless steel is very less magnetic and also very rigid. The construction needs to be as little with as little resonance as possible. That's why we did this structure and why we did a lot of calculations how to do the honeycomb and where to place them. So nothing was decided or defined before production. In front of this core have the magnetic system and of course the cantilever and the coils. Inside the cartridge you'll find that we have a new one-piece rear magnetic yoke or rear yoke with a pole cylinder where it's like one piece instead of making these 2 parts, gluing or assembling. It's more sturdy, it's more complex to produce, but it's more sturdy and it's easier to assemble. So we decided to do a more advanced configuration to do a more stable and more refined product. We also have created a new magnet. It's a very powerful magnet, but nobody will like an oversaturated magnetic system because then you will not be in control of all the flux lines being in place of where you need them for the armature and the coils. Therefore, despite a very high output of 0.4 millivolts for all the cartridges, it's in fact a slightly reduced magnetic system compared to the previous generation, but highly complex structure with a very precise, I would say, flux line density in the magnetic gap. All in all, the result is a precise overall channel precision and a wide channel balance, channel separation, of course. From the smallest version or the cheapest, the 299 MC X10, you'll actually face a 0.4 decibel precision of the channel balance. It is better when you go through the series where you are going from the tipped elliptical diamond to the nude elliptical diamond on the MC X20. There you'll extract more details from your records, and also you are more into the scenery of the music you're listening to. It gets even more and more exciting when you're going up to the X30 or even X40. The X10, 20 and 30 are using elliptical, nude elliptical or nude fine line diamonds, all mounted on aluminum cantilevers. With the X40 we chose to go one step up again. So it's a nude ciabatta mounted on a boron cantilever. Normally that is found on very high-end cartridges, so it's actually at the 999 or 999 euros price point for the X40. It's a tremendous result at this price point. They will be available from May 15, 2025. Again, we didn't want to just achieve a new facelifted model. We didn't want to just adjust slightly.